Hello everyone, welcome to the lecture Introduction to the Analog Communication. These are the learning outcomes. At end of this session, students will be able to describe the basic need for modulation in communication system. We'll see the communication system. The basic components are transmitter, channel or medium and the receiver. So this is the block diagram of communication system. It consists of transmitter, channel and the receiver. And the transmitter consists of transducers, amplifiers, encoder, decoder circuits. As we know that information may be in any type, such as it may be a video, it may be an audio, it may be a digital input. So it can be anything. So it can have to convert into the electrical signal. So the transducer is used in the transmitter. And then amplifiers, encoders and decoders. Next, that information is being transmitted through a channel, as the channel will consist of two mediums. One is the wired and second one is your wireless communication. In wired communication, we can use a twisted pair cable, coaxial cable and fiber optics cable. As twisted pair cable is used where the few data can be transmitted up to a few kbps. If you want to send more than that data, you have to use a coaxial cable that is supported up to few megahertz. If you want to send more the data above that, we have to make use of an fiber optics cable up to 100 gigabytes. These are the wired. And next one is your wireless communication. In that we may use the radio communication, like the radio signals which are being transmitted in the FM signals. So that is the medium which is known as an wireless medium. And last one is nothing but it is an receiver. In the receiver, whatever the information has been transmitted, we have to get that same original information at the receiver. And the most important thing is the noise. The noise which is added to the channel. The noise are of two types, that is a man-made noise and the natural noise. Natural noise are the cosmic rays, the sun radiations which causes to affect the signal. And man-made noise are the industrial noise, pumps, scooters, whatever the noise has been produced by the man-made. So they are known as a man-made noise. So this is total the communication system, that is transmitter, channel, receiver and the noise. So if you change to any communication system, this will be the basic block diagram for the analog communication. Next, we'll start with the baseband signal or the modulating signal. The next one is the original information signals are analog or digital. They are all referred as a baseband signal. Putting original signal directly into the transmission medium is called as a baseband transmission. But there are some limitation of the baseband transmission. For example, voice signal cannot travel a longer distance in air so that the signal get attenuated rapidly. So the baseband signal or the information signal or the modulating signal is one and the same. We cannot transmit the voice signals a longer distance in air as the signal get attenuated rapidly. So to avoid this, we have to do an modulation. Modulation is the process of superimposing a low frequency signal, that is nothing but the baseband signal, on a higher frequency carrier signal. So whenever you're going to send information which is of low frequency, we have to superimpose on the higher frequency carrier signal. So there are three types of modulation technique: amplitude modulation, frequency modulation and the phase modulation. So in amplitude modulation, as we are going to see in this figure, so this is the modulating signal or the baseband signal and this is the carrier. We are going to superimpose the signal on the carrier. So this is an output of the amplitude modulation. So in amplitude modulation, we are going to change the amplitude of the carrier signal, the amplitude of this carrier signal with respect to instantaneous time of the modulating signal. So we'll get an output as an amplitude modulated wave. Next, this is the frequency modulation. So this is an modulating signal and this is the carrier. Now we are going to change the frequency of this carrier signal by keeping amplitude and the phase constant with respect to modulating signal, the amplitude of the modulating signal. Here you will get, for the positive half cycle you will be having the max frequency, for the negative half cycle you will be having a minimum frequency. So this is an frequency modulated wave. Next one is the phase modulation, in which you are going to change the phase of the carrier signal with respect to a modulating signal by keeping amplitude and frequency constant. So as we have studied the three types of modulation, that is an amplitude, you are going to change the amplitude of the carrier signal with respect to an modulating signal. In frequency modulation, we are going to change the frequency of the carrier signal with respect to an modulating signal. And in the phase modulation, we are going to change the phase of the carrier signal with respect to an modulating signal. So why we have to go for a modulation? What is the need of a modulation? First is the most important thing, to reduce the height of antenna. As we know that lambda is being calculated by lambda is equal to c by f, where the c is the velocity of light and f is the frequency at which the information is being sent. And minimum antenna height is required to receive the signal properly is lambda by 4. The information signal is often low frequency and therefore the wavelength is very high. As frequency is low, the lambda will be very high. And if we transmit such signal directly, the size of antenna will be a very large and it is impossible to build. Hence, the direct transmission, it is not practically possible. So we need to have more frequency. So that's why the lower frequency signal is superimposed on the carrier frequency, which is having a higher frequency. So that's why we have to go for modulation to reduce the height of antenna. Automatically, if you increase the frequency, the height of antenna goes on decreasing. So we can build such type of antennas practically. Next, avoid the mixing of signal. If we transmit the information signal directly, the signals from the different transmitter will also get mixed up and the information will be lost, as the information signal may have the same frequency transmitted from the different transmitter. But if we mixed with the different carrier frequency, it will avoid the mixing of signal. Next point is increases the range of communication. When the wave has a large frequency, the energy associated will be also large, so it can travel a longer distance. Next, improves the quality of reception. By doing modulation, we can transmit the signal with a quality. We can receive the signal with a quality of reception. Like in FM, it is more noise immunity. Okay, so these are the points we have to remember why we have to need for a modulation: to reduce the height of antenna, avoid the mixing of signals, increase the range of communication, and improves the quality of reception. So these are my references, and thank you.